You have your NH2, but also in this Witter ionic configuration, NH3+. Here you have your R group, and then you've got your extra H on the end. So this is a keto acid. So, you know, we hear about those like ketoacidosis, right? So look at the difference between these. You've still got an R group, you've still got your carboxylic acid group. What you don't have is this middle part, and instead you have a keto group, right? Like this is a ketone, like aldose, ketose, right? So we've got a double bond O in the middle of the molecule. So when you take an aminotransferase, you're moving the amino group, the nitrogen-containing group, from one molecule to the other. When that happens, this amino group hops over here, and the H comes with it because the carbon gets jealous, right, and needs more. And then, but the double bonded O hops over here instead. So you are transferring the nitrogen part from one to the other. What's the advantage of being able to do this? There are a couple of reasons that our body has evolved to do this. One is because you only have so many enzymes available. Like when we go into the urea cycle and we're in the mitochondrion, there are only so many enzymes, and you need to be able to process urea and stick it to something and send it out so it doesn't become ammonium and change the pH of the system, right? So if you can change the amino acid from something that can't be processed in the mitochondria to something that can be processed from the mitochondria, you have more options. So this will make more sense in a second when I go to the urea cycle. The other thing is sometimes, what if you just need an amino acid you don't have, right? What if you're really running really low on one particular amino acid? Even if this costs energy, the cost of not producing the protein may be more detrimental to the cell than the energy it takes to swap amino acids, right? If you've got a keto acid, but you don't have that amino acid, you can trade. So we'll come back to this at the amino cycle. I mean at the urea cycle, sorry. All right, and here's the second one. So, do you guys remember what alpha-ketoglutarate is if we think back to the Krebs cycle? It's an intermediate. It's like, if you go around the circle, it's kind of down here somewhere, okay? So, if you can take an amino acid, this is glutamate or glutamic acid, right? And you can change it to alpha-ketoglutarate, can you enter the Krebs cycle? So yes, you can. So we talked about that it's expensive to enter the Krebs cycle, right? That it costs, running an amino acid all the way through the entire Krebs cycle costs more energy than it nets. But if you're down here in the middle already, and you enter the Krebs cycle in the middle as opposed to at the top, you don't cost any energy. You make some, and then you're at a net even. So, we're going to do this again, hang on. So for this thing, for these two figures, here's what I want you to know. Bless you. For the first one, you've swapped, right? You've changed from an amino acid and a keto acid to a keto acid and an amino acid. For the second one, you're going from glutamate, and don't worry about the rest of this. We're not going to draw out all those particulate, to alpha-ketoglutarate. This is an amino acid. This is not only a keto acid, but it is a Krebs cycle intermediate.
Because it's getting rid of the nitrogen inside, right?
So it is, yeah. So it is. So, but you're producing ammonia down here, and then you are going to have to figure out how to get rid of that ammonium ion, right? And that's where we end up more in the urea cycle. We have to get rid of that ammonium. So there's a specific reason to do this.
So I'm sorry, deamination is always going to produce ammonium.
In this, well, yes, because deamine means you're taking it off.
And it's
so
going to grab another hydrogen.
Exactly. So then you have to put it somewhere else. Okay. So for those two, let's go back to this. All right. Right. Okay. So, but before everybody gets totally freaked out, this is OChem, right? Like, there's nothing that I'm telling you that isn't generally familiar in the back of your heads. A keto is a double bonded O attached to a C in the middle of a molecule, right? An amine group has nitrogen in it. You guys had to memorize the structure of an amino acid. You had to memorize multiple ketones. We just did ketoses, again, with the C double bonded O. So it seems like it's new, but it's none of the pieces are new. It's the way we're putting it together that's new. So if you can look at the pieces, if you're like, okay, keto acid, keto has double bonded O attached to a middle molecule C. I can find that one, right? An amino acid, I know what that looks like. Now you can go transaminase. We moved the nitrogen, and then you can find yourself in a better place to understand the reaction.